This morning I'm starting work on a Gottlieb Monte Carlo System 80B MPU, and the client had begun to attempt to abate the alkaline corrosion. A couple of components have been removed, and some kind of acid was used to try to remove the alkaline corrosion, and that really never works. So the right procedure here is to remove most of this reset section, as we have detailed in the pin wiki, and replace it with a equivalent of a Dallas Maxim 1811 reset generator. This chip will have to go. Daughter card will be replaced with one of the ones that I make nowadays. Whoops. And this TC1 connector, I always remove that and just throw it in the box and tell people not to use it, because it causes, the reset card causes more trouble than it's worth. We got a little corrosion on these 4.7K pull-up resistors for the switch matrix, so those will have to come out. I'm going to remove at least this first dip block to make sure there's no corrosion beneath it. There's corrosion over here in these clock circuit resistors. The good thing is that the edge connectors are not corroded. So if the edge connectors are gone, then it's really debatable, I guess, whether or not these things can be repaired. Although it is possible to refit new edge connectors, I guess. I guess I could build a card to do that. Somebody's worked on the switch matrix here. These are the row and column, or maybe I've got that backwards, 7400s and 7404s. There's no slam switch modification yet, so I'll do that too. So all this stuff in here is going to get removed first thing. Getting started on the sanding. I'm outside now, hence the bright light. I use a old 12-pin Molex female housing as a sanding block, and then this is probably, I don't know, 240 or so sandpaper. I didn't remove the 6502 yet because I want to see how pervasive the corrosion was. Somebody's removed that in the past, because you can see the solder that's wicked up these legs. We'll see. So we are on the bench with this Monte Carlo System 80B MPU. I've implemented the slam switch mod by connecting the lower leg of those two components. I have done a lot of alkaline corrosion abatement, and unfortunately you can see some traces where the corrosion just ate right through to the PCB, and I have had to install a few jumpers. Like there's a blocking diode from the lower left terminal of this CR2032 up to the 62 ohm resistor, because that trace was severed right there. Normally I'd put it on the back of the board from here to here, but again, this trace goes up to here and that was severed. The long trace that goes underneath these 4.7K pull-up resistors all the way over to this via was severed. So I just connected a jumper from there, tack soldered it to there to the via over here, which eventually goes down to Z2 pin 12, that is. And I've removed all the other reset components and installed the equivalent of a Dallas Maxim DS1811. A few more jumpers up here to effect that modification. A replacement 100 microfarad cap. My own, I'll call it my own design, but it was heavily influenced by Ed at Great Plains Electronics, and this daughter board here in the single position, and those work beautifully. I did not socket the 5101. It's not an AMI component. Let's see what happens when I boot it. I've got it on my bench, obviously, and this is a Lizzie System 80B display, which a friend of mine out in California, Mr. Cheddar, helped me obtain. That is a normal boot, and we're in attract mode, and we are our driving lamps on the playfield, this board came from Pascal Janin in Europe. It's kind of nice, but you can see I had to do something janky to connect it up here. And if I were designing this board myself, I'd put 0.156 headers here. But this was designed to accept the Gottlieb edge connectors, which I do not prefer for a test device. All right, so we can, put this board into test with my janky old switch matrix replicator based on the design by Jim Paulson. Rest in peace, my friend. And this is the diagnostic start button, and this is the credit button that I've got marked. So let's start diagnostics. And I'm going to skip past the adjustments, I guess, and we can see that lamp test is operational. Now we'll do relay and solenoid test. This driver board is from a known working System 80 game that I also have in for repair. But I just want to make sure that the device selects were being properly conveyed across the gigantic wire harness, the dual edge connector to the driver board. And in fact, they are. So let's do switch test next. This is important. Some of the Z11 through Z15 chips have been changed here, so I'm going to go across the diagonal of the switch matrix. Gottlieb fortunately reports, or nicely reports, I'll say, all 64 switches. And so that proves that the entire switch matrix is operating correctly. Dip switch settings of 3, 3, AA, and 4B. 3, you gotta think in hexadecimal, 3, 3, AA, 4B, that is correct. And memory test, or display test, sorry. This Pentatech, Pentatech, not Pentatech, Lizzie display is quite nice. Highly recommended. Memory test, where it tests the 5101 and gives you a checksum for prom 1, which is the prom way over on the right-hand side of the MPU. Prom 1 socket, prom 2 socket. I guess that's just generically called the game ROM socket in 80B, but it used to be the U2, U3 socket. So we are done. I love it when I can follow the sort of the recipe that we have documented in the Pin Wiki for repairing these System 80 boards. These boards are built way better than any aftermarket board, any aftermarket System 80 board that has ever been built. Well, thank you so much for sending it, and you will be high rolling, I guess, soon.